Imagine you're standing on the absolute highest point of the Shanghai Tower.
Oh, wow. Okay, starting right at the top.
Right at the top. You're hundreds of stories up, and you are leaning over the edge of, well, one of the tallest mega-tall skyscrapers on the entire planet.
Just looking straight down at the pavement.
Exactly, just looking straight down. And I want you to feel that sudden rush in your chest.
Yeah.
You know, that dizzying, stomach-dropping wave of vertigo where your brain is just screaming at you to step back.
Oh, yeah, I hate that feeling. It's like a primal panic.
Right. Well, that massive, terrifying void of empty air, that is the exact distance from the window of your car down to the river gorge when you're driving across the bridge we're looking at today.
It's a scale that almost defies human comprehension. I mean, you are literally suspended in the clouds.
Which is exactly why we are jumping into this deep dive. Our source material today covers the Huajiang Canyon Bridge.
Yeah, which opened up in late September of 2025.
Right, in a really remote Chinese province. And it is honestly a complete redefinition of what human engineering can even do.
It really is.
Okay, let's unpack this. We're going to explore how a single bridge shattered world records, conquered these impossible geographical obstacles that isolated people for centuries, and then inexplicably decided to double as a global hub for extreme sports.
Which is the best part. But to really grasp the audacity of this project, you have to kind of throw away the illusion that your GPS gives you.
What do you mean by illusion?
Well, you know, when you look at a digital map, the world is just this flat, two-dimensional abstraction.
Right, like a video game map.
Exactly. You see point A, you see point B, and your navigation app just draws a neat little straight line right between them.
Yeah, it looks so simple.
It does, but it completely hides the brutal reality of the Earth's surface.
Because you drive out to that straight line, and suddenly the Earth just, well, drops away.
Yeah, you're staring down this jagged, seemingly bottomless gash in the planet.
And historically, if you hit a canyon like that, you either turn around or you spend like days navigating this treacherous dirt path all the way down to the bottom and then painstakingly back up.
Right, but the engineers here chose a slightly different route.
They decided to just float a highway across the sky.
Basically, yeah.
Let's get into the sheer physical dimensions of what they built here in Guizhou province. It crosses the Beipan River, and the bridge itself measures 2,890 meters in total length.
That's almost 3 continuous kilometers of asphalt and steel and concrete just suspended over a void.
It's mind-boggling.
Yeah.
I mean, if you're driving across it at normal highway speeds, you are out over the open gorge for a really significant amount of time.
You're just hanging there.
Yeah. And the main span, you know, the section hanging purely between the two massive support towers, that alone is 1,420 meters.
And just to hold up that specific amount of weight, they had to build support towers that are, honestly, they're essentially skyscrapers themselves.
Right. The north tower is 262 meters tall, and the south tower is 205 meters tall.
And think about the logistics of that for a second. You are building a 262-meter concrete tower, but not in some flat city center with, you know, easy access to cranes and paved supply lines.
No, you're perched on the precarious edge of a mountain cliff.
Exactly. The staging and the material transport alone for a site like that is an engineering marvel.
Just getting the trucks up there.
Right. Every single ton of steel, every cubic meter of concrete, it all has to be hauled up these winding mountain passes before it even becomes part of the bridge.
But the height of those towers, that isn't even the record-breaking part.
No, it's not.
The statistic that absolutely breaks my brain is the clearance below the deck.
The drop.
The drop. The actual road where the cars are driving sits 625 meters above the water level of the river gorge.
Wow.
That is the drop we were visualizing at the start. 625 meters of pure, empty air. So it holds the title for the highest bridge in the world.
And there is this really fascinating, almost paradoxical regional detail buried in the geography here.
Oh, what's that?
Well, by hitting that 625-meter mark, the Huajiang Canyon Bridge claimed the world record, right? Do you know whose record it actually broke?
I think I saw this in the text. It was the Douge Bridge, right? Which crosses the exact same river.
Yes. The Beipan River. It's just 200 kilometers upstream.
That is wild. The same river valley holds the top 2 highest bridges on Earth.
Yeah.
It's like the river has basically carved a trench so hostile and so deep into the earth that engineers are forced to literally surpass their own world records just to get from one side of the province to the other.
It really speaks to the absolute sheer hostility of the terrain out there. I mean, building a megastructure in an environment that unforgiving, it does not happen by accident.
No, and it certainly requires a monumental financial commitment.
Oh, a massive one. Construction on this project began all the way back in January of 2022. They spent years just battling the altitude and the elements.
And then they finally ran load tests in August of 2025.
Right.
Wait, actually, we'll pause on that for a second. I always see the phrase load tests thrown around in these engineering articles, but what does that actually look like for a bridge hanging 625 meters in the air?
Oh, it is easily one of the most tense phases of construction.
I can imagine.
Because before you let the public anywhere near it, you have to prove that all your mathematical models actually hold up in the physical world.
So what do they do?
Well, for a suspension bridge of this scale, they literally drive convoys of fully loaded, heavy commercial dump trucks out onto the deck.
Wait, really?
Yeah, dozens of them just parked end to end. They're mimicking the absolute maximum weight the bridge could ever conceivably hold in, like a catastrophic traffic jam.
That sounds terrifying for the guys driving the dump trucks.
Right. But the engineers then meticulously measure how much the bridge deck sags or, deflects under that immense pressure.
Oh.
They're checking the tension on the cables, the stress on those massive towers, and only when the bridge flexes exactly as predicted and then springs right back into place do they actually sign off on it.
Wow. Well, they obviously passed because it officially opened to traffic on September 28th, 2025.
They did.
And that brings us to the financial reality of all this. The construction cost was 2.1 billion RMB.
Which is roughly a 290 million US dollar equivalent, though in terms of domestic purchasing power and the sheer scale of raw materials that buys in the Chinese infrastructure sector, it is an incredibly massive public works expenditure.
Wait, 2.1 billion RMB for a single bridge.
Yes.
The math just isn't mathing for me here.
How so?
Because the text says this bridge carries the S57 Lujianlong Expressway, right? And it turns a 70-minute drive into a drive that takes just over 1 minute.
Correct.
I am struggling to understand how any government justifies spending that kind of money just to save commuters 69 minutes. I mean, is an hour of saved driving time really worth billions?
If we connect this to the bigger picture, you have to look down at the ground beneath the bridge to really understand the justification.
Okay, what's on the ground?
Well, Guizhou province has historically been a very economically depressed area, and that poverty is directly tied to its geography. The landscape there is defined by karst topography.
Right, the text mentioned that. It's like Guizhou's ground is basically made of Swiss cheese.
That is a very good way to put it, yeah. It's a landscape dominated by limestone that, over millions of years, just dissolves and washes away.
Leaving behind what?
It leaves behind these massive, sudden sinkholes, deep underground cave systems, and these dramatic, really jagged, rocky
That
spires.
sounds gorgeous for a postcard.
Oh, it's beautiful to look at, but it is an absolute nightmare if you're an engineer tasked with laying down a flat, stable stretch of asphalt.
I bet.
And it's a nightmare that acted as a literal fortress wall around the province for centuries.
Wow.
Before this bridge, if you wanted to cross that canyon, you weren't just driving. You were navigating treacherous, winding mountain switchbacks down to the valley floor, loading your vehicles onto slow-moving river ferries, and then climbing painstakingly back up the other side.
That sounds awful.
So those 69 minutes you mentioned, that is not just a frustrating delay on a morning commute.
What is it then?
It is a profound friction point that stifles all economic activity. I mean, think about the logistics. If you're a manufacturing company and it takes your fleet of commercial trucks an extra hour and a half of burning fuel and navigating dangerous mountain passes just to deliver a shipment of basic goods.
Your profit margins just vanish.
Exactly. Or if you're a local farmer in Guizhou trying to get your produce to a wider national market before it spoils, that canyon is essentially a death sentence for your business.
Because industries just refuse to invest in areas where the supply chain is that physically compromised.
Right. So the bridge isn't a shortcut. It is an economic lifeline.
Right, I see. You aren't paying for a shorter drive. You are paying to unlock an entire province's economic potential.
It transforms a formidable geographical barrier into a high-speed, bustling gateway. Suddenly, heavy freight can move seamlessly.
Yeah.
Local businesses are integrated into the broader national economy in a way they literally never could be before. You are dissolving the isolation that causes the poverty.
That is fascinating. But, I mean, if you are betting the economic future of an entire province on a single bridge hanging 625 meters in the sky,
Yeah.
with fleets of commercial trucks rolling across it day and night, you need to be absolutely certain the thing isn't going to snap.
Oh, definitely.
Because it is subject to incredibly high winds up there, massive temperature shifts, expanding and contracting the steel, and just the constant punishing stress of heavy traffic.
You cannot just pour the concrete, string the cables, and hope for the best. At that altitude, safety requires knowing exactly what the structure is experiencing at a microscopic level at all times.
And here's where it gets really interesting. The engineers essentially gave the bridge a nervous system.
They did.
The source text details how they embedded live monitoring directly into the structural DNA of the bridge. They used a fiber optic load cell cable woven right into the carrying cable strands to provide real-time data on the bridge's health.
It's brilliant engineering.
It is, but reading through the specs, I hit a detail that made me highly skeptical.
Oh.
It says this fiber optic cable is embedded in only 3 out of the 217 carrying cable strands.
That's correct, yeah.
Why cheap out on the sensors?
Yeah.
I mean, if you are going through the multi-billion RMB trouble of wiring up a 2,800-meter-long bridge, why not monitor all 217 strands?
It seems counterintuitive, right?
Yeah. How can 3 possibly be enough to know if a megastructure is failing?
Well, it is a very common intuition to assume that more data is always better. Like, why not wire every single inch? But in the physics of structural engineering, particularly with suspension bridges of this magnitude, the goal is actually elegant efficiency.
Okay, unpack that for me.
Think of the main suspension cable like a massive tug-of-war team.
Okay, a tug-of-war team. I'm with you.
If you have a team of 217 people all pulling on a single massive rope together, they are all working in concert, they are all experiencing the exact same macro-environmental stresses,
Right.
the same wind pushing against them, the same weight pulling back. You don't need to walk down the line and ask every single individual person exactly how hard they're pulling to understand the total force.
Oh, I see.
If you attach a highly calibrated strain monitor to just 3 carefully, evenly spaced people on that team, you know the exact tension the entire group is exerting.
Because they are bound together. The behavior of the 3 perfectly mirrors the behavior of the whole.
Precisely. By embedding fiber optic load cells in a strategic representative sample, engineers can extrapolate the live stress of the entire structure with incredible accuracy.
That makes a lot of sense.
And we really should talk about how those fiber optic cables actually work, because it is brilliant.
Please do, because I just picture like a regular internet cable. How does a glass wire tell you if a massive steel bridge is straining?
Okay, so they shoot continuous pulses of light through the microscopic glass fibers embedded in the cable, and glass is incredibly sensitive to physical manipulation.
Right.
When a heavy convoy of trucks drives over the bridge, or a massive gust of wind hits the canyon, the main steel cables stretch and bend microscopically.
Okay.
That physical strain transfers to the embedded fiber optic cable, causing the glass fibers inside to undergo what we call microbending.
So the glass actually warps slightly under the pressure.
Yes. And when the glass warps, it changes the way the pulses of light refract and bounce back to the sensor hub.
Oh, wow.
By measuring those minute changes in the light's reflection, the computer system can instantly calculate the exact physical tension and stress the bridge is experiencing in real time.
That is wild.
Yeah.
It really is a nervous system, like literally pain receptors for a steel giant.
Exactly. And introducing complex, delicate fiber optic sensors into high-tension steel is mechanically very difficult during the spinning process of the main cables.
I can imagine.
Every sensor you add introduces a potential point of friction or, a mechanical weakness. So by limiting it to 3 meticulously chosen strands, they get all the high-fidelity, real-time data they need to ensure structural integrity without overcomplicating or weakening the mechanics of the cables themselves.
Wow. So we have this flawlessly monitored, mathematically perfect structure just floating above the clouds.
Yeah.
It's safe, it's efficient, and it's solving a massive economic bottleneck for Guizhou.
A total game changer for the region.
But they didn't just stop at making it a functional highway. Someone looked at the blueprints for this beautifully engineered crossing over a stunning deep gorge, and they had a wildly creative realization.
Yeah, they did.
They realized the bridge didn't just have to be the transport. It could be a tourist destination all by itself.
What's fascinating here is this is where the project transcends traditional public works infrastructure and becomes something entirely new.
because integrated right into the architectural design of the bridge are these mind-bending tourism facilities. It's not some retrofitted afterthought either. It is built right into the concrete and steel.
It's fully integrated.
Yeah. For example, below the car deck, there is a glass sightseeing walkway.
Oh, just imagine the sensory experience of that.
I'm getting vertigo just thinking about it.
Right. You're walking on a transparent floor. Above your head, heavy commercial trunks are rumbling past, physically vibrating the structure. And beneath your feet, there's nothing but 625 meters of empty air before you hit the rushing waters of the Beipan River.
And it gets so much crazier because the designers look at the immense height of those support towers, the ones perched on the cliff edges, and they capitalized on them.
Oh, yeah.
Beside one of the main towers, they constructed a 207-meter-high, glass-enclosed elevator and staircase.
An elevator ride scaling the side of a mountain gorge inside a transparent box.
A 207-meter vertical drop while you are standing in a glass box.
Incredible.
And, okay, on top of one of those bridge towers, sitting exactly 800 meters above the valley floor, is a specialty coffee house.
That is just...
I just have to laugh at the sheer absurdity and thrill of this concept. Imagine you're on a road trip, right? You pull over at a highway rest stop. You take a massive glass elevator up the side of a bridge tower, and you sit there sipping a vanilla latte 800 meters in the sky.
It's literally monetizing the altitude.
You are eye level with the clouds, while the highway traffic just speeds along hundreds of feet beneath you.
And if the caffeine isn't enough to get your heart rate up, the bridge also includes built-in facilities for bungee jumping and paragliding.
Right. They engineered platforms into the multi-billion RMB expressway specifically so people can voluntarily throw themselves off it.
There is a profound economic brilliance to this dual-purpose design, though.
How do you mean?
Well, the planners looked at the problem of Guizhou's historical isolation, and they approached it from two distinctly different angles simultaneously.
Right.
The primary goal is fulfilled, obviously. The highway brings commercial shipping, it solves the logistics nightmare, and it provides traditional economic integration for the local industries.
Right.
But they recognize that the very thing that kept people out, that dramatic, terrifying karst topography, is the exact scenery that will draw people in.
They turned their biggest geographical liability into their biggest asset.
Precisely. By turning the infrastructure itself into an engine for extreme tourism, they are creating a completely new revenue stream for the province.
That's so smart.
Extreme sports enthusiasts, international sightseers, architecture nerds, and, people who just want a really crazy cup of coffee. They will travel from all over the world to experience the sheer scale of the Huajiang Canyon Bridge.
Yeah, they absolutely will.
It is a masterclass in maximizing the return on a public works investment. You aren't just facilitating trade, you are creating an entirely new industry on top of a bridge tower.
It is the ultimate two-for-one deal.
Mm-hmm.
So what does this all mean? When we step back and look at the whole picture here, we're looking at a true marvel of the modern world that forces us to basically rethink what infrastructure can be.
Absolutely.
We have the 2.1 billion RMB investment that conquered impossible jagged limestone mountains, took a grueling, day-ruining 70-minute trek through a dangerous canyon and turned it into a 1-minute flight across the sky.
Yeah.
It provided a vital economic lifeline to a historically isolated province, plugging them right into the national supply chain. And because human beings are delightfully crazy, it doubles as an extreme sports hub with a nervous system made of light, where you can drink coffee above the clouds and bungee jump off a world record-holding structure.
This raises an important question. As our global infrastructure projects become increasingly monumental, and as they integrate more seamlessly and dramatically with the natural landscape, it challenges our fundamental assumptions about travel.
How so?
We have always viewed roads, tunnels, and bridges simply as the mechanisms we use to get to our destinations.
Right, there was just the journey.
But if a functional suspension bridge hanging over a gorge can simultaneously operate as an extreme tourism hub, when does the commute stop being the journey and start becoming the vacation itself?
Wow.
Imagine what other everyday pieces of infrastructure, our train stations, our water dams, our highway interchanges might evolve into as engineering continues to blur the line between utility and destination.
I love that thought. The obstacle in the middle of the map might just become the best part of the trip. Well, thank you for joining us on this deep dive into the Huajiang Canyon Bridge. Keep your curiosity alive. Keep looking for the stories hiding behind the concrete and steel, and we will catch you on the next one.